Good evening, everybody. My name is Marty Geyer, and I'm your GSP295 instructor. And what I'm going to do here is give the series of video lectures about various topics in the class. I'm going to try to give you a couple for each week, essentially, to go over each of the main concepts. I know a lot of people are auditory learners, a lot of people are visual learners, a lot of people like to just read and do learners, essentially. But sometimes some people like just a physical lecture, and since we don't have that available because we're an online class and getting together is impractical and kind of defeats the purpose of an online class, as a supplement I'm giving you these videos so you can see my cues and craziness and see the whiteboard and see me do some of these things. I'm going to stick to not doing programming directly, mostly because this is a whiteboard, not a computer, as you may have noticed, and it doesn't lend itself very well to programming, and also because that's pretty well covered by your textbook and by the lab assignments, which are just going to actually have you do this kind of thing. So I'm going to instead focus on the concepts and try to head off and give you answers to questions that I found that students normally have and go through a process with you. By all means, this shouldn't answer every and all questions, so do ask me questions, bring up good suggestions, and I might make another video out of them to cover a particular topic if you're confused about something. So please do suggest. So what I have written up here now is from the first lab, and we're also going to talk about ADTs here in this video. So this is a simple square matrix like we're talking about in our lab, and this is the 2x2 matrix. And I know that there's various math backgrounds in the class, so you might not be so familiar with matrices. Chances are you've done them at some point, but may not recall everything about them. So this is going to be pretty simplistic, and the idea of this assignment is not to test your integral knowledge of whether you can do determinants and crazy operations on matrices of different values, sizes, and forms, but rather can you accurately abstract a ADT, write it, code it, document it, etc. from an application domain problem, which is a square matrix. So here's our basic problem. We're in the world of mathematics, and we have a set of matrices, and we want to add them, subtract them, and do stuff to them. So remember from the chapter textbook, there's three levels. There's the abstract level, the application level, there's the logical level of the abstract level, and there's the implementation level. Three separate layers, right? So you go from the application to the logical to the implementation, and this is also the abstract. And this is where ADT lives, is in this middle level. And notice this is different from the application level. At the application level, the user doesn't care about what operations we have to do internally to memory to make this happen. All the user cares about is, I want to add this and this, or I want to subtract this and this, or I want to create a matrix that looks like that. Those are application level, domain level things. You have a mathematician who wants to do something to a matrix. That's an application level. The logical ADT level is what we're going to go through, and then implementation level is what you're going to do in the lab. And so we're going to stay away from that, but that's pretty obvious to everybody in the class. I think this is the level you're familiar with. This is actually coding up the assignment itself. So, as a quick review, here's what addition looks like on a simple 2x2 matrix. Remember, all you do is you add each individual position. So 3 plus 2 is 5, and that's where we get this entry here. And minus 1, 1 is 0. 1 minus 2 is minus 1, and 3 and minus 2 is 1. Same thing with subtract, you're just going to subtract them. So when you're coding this, hopefully this is not going to present any challenge to you. If you do have trouble with any of the mathematics, please ask me, or use your favorite friend, Google or web search, to look up a little more. But this is pretty simple math, so you shouldn't have any trouble. So now, what operations do we need? Well, at an application level, we just want to put matrices, create a matrix that looks like this, add them, etc. At the ADT level, we need operations at an abstract level that will do things to perform those domain operations. So in order to add two matrices together, we need to have them in the first place. So the first set of ADT operations are going to focus on making a new matrix. So we need to actually create a matrix in memory. And this is to be essentially n by n dimensional array, depending on the size. We need to make the matrix. We're actually these can be different depending on the ADT, as we'll see in the course. We're combining them in the lab, so creating and making is the same thing. What else did we talk about in the lab? We're going to do, I forget what we called it, but it's clear. You can see. Make empty, yes, so it's clear. So make empty. Let me not confuse you. Let's just call that create. And make empty. So this is an initialization. Now, a mathematician doesn't care about initialization, right? So this is why this would occur at the logical level, ADT level. What we need an initialization as a programmer in order to make sure that all the values are as we expect them in a dimensional array that holds a matrix. And then we might want to assign a value, which is set value. And then we might want to actually do, of course, things that we want to do with matrices, like add, subtract, maybe multiply, etc. So there's more here than just the simple application operations. We also have to make, initialize, create. We have to set the values in each individual one. And then you might have various other ADT operations as well. For example, in this lab, we're going to ask you to do a print. So this is a operation to let somebody view what's in the actual matrix itself. In an application domain, that doesn't exist because you just see it. But in a programming domain, logical domain, you need to be able to print to the screen for the user to be able to see it. At an implementation level, you're actually going to create these functions and code them out, put the proper initialization parameters, return values, preconditions, postconditions, test cases, and all of the stuff that we go over in the first few chapters. I'm going to leave that to you, but I want you to understand how these levels work between them. So, at an ADT level, we would focus on the logical components of a data structure, an algorithm, that allow you to perform useful, meaningful operations. And it's important you get this list right. For any given data structure and algorithm, your book's going to go through this, and in each assignment you'll be asked, usually be asked to very specifically code certain ADT operations, so you won't have to come up with the list as much just to keep uniformity. But in the real world, you'll actually have to brainstorm from the application to the logical level. In the first couple of chapters, review how to do this. I hope that's been helpful, and we'll see you next time for another video lecture.